FHIR, or Fast Healthcare Interoperability Resources, is a healthcare data standard created by HL7 International to meet the interoperability needs of the current healthcare data environment. Over the past few decades, more and more systems need to be connected, so a data standard of this kind has become essential. In fact, compatibility with the FHIR standard is now federally mandated for healthcare IT systems in many countries. With data now stored in many places, such as pharmacies, home devices, and mobile devices, interoperability and the FHIR standard make it possible to see all this data in one place in real time. FHIR was designed with key considerations in mind, including the need to move data from offline to online, as well as data transparency requirements. As a standard, FHIR can also handle both narrative and coded data. To put it simply, FHIR is a representational state, or REST API. FHIR encompasses the specification for requesting and receiving data, as well as an agreement on the meaning of the data in healthcare. Let's take a look at the elements that make up FHIR. First, FHIR resources are logically discrete data concepts such as a patient, medication, or document, which have a defined meaning and a known location on a server. A FHIR resource includes all the data elements necessary to define the data concept. For example, the patient resource includes elements such as given name, family name, and birth date. The FHIR specification also includes profiles, which are implementations of clinical information models defined for specific use cases, such as a procedure. FHIR profiles exist for each resource required for the use case, and they consist of all the necessary rules and relationships, value sets, and FHIR extensions. We'll discuss FHIR extensions in more detail later. By using shared profiles, healthcare applications can use FHIR across different interoperability paradigms without any transformation required. Data expressed as FHIR can be used in messages, documents, and REST APIs. Since FHIR is machine readable, it can also be used in services, such as decision support services. Interoperability comes from using the same FHIR profiles in each system. True interoperability comes from exchanging information and having the intended meaning come across. While humans are very good at interpreting meaning, computers can only understand exactly what the data says. For example, two people describing a zebra as either a white horse with black stripes or a black horse with white stripes would quickly figure out that these mean the same animal. However, these descriptions are completely different to a computer. To ensure that the same descriptions are used across systems in healthcare, a clinical information model must be used. This includes the descriptions of healthcare data concepts for a particular use case, rules of how the data is used, vocabulary or terminology bindings, and the relationships between data. A FHIR profile is the implementation of a clinical information model. To understand the importance of a profile, consider a patient's medical history report from an EHR system that you print out and cut into individual data elements. On one of these strips of paper is the phrase, diabetes type 2. While we know what this phrase is, the context is missing. Diabetes could be a condition the patient has, a condition they used to have, or even a condition their mother had based on family history. FHIR profiles provide context by defining the relationships between data elements and resources. The terminology binding in these profiles uses a FHIR terminology server, which contains all of the codes and value sets needed for a FHIR profile. The codes used for a particular element make up a value set. All applications, systems, and operations using the profile can access the server, ensuring that the same codes are used to refer to the same data elements within resources across systems. The FHIR standard includes data elements that are used in 80% of systems, but it also defines how to create a FHIR extension as part of a profile to represent data elements for a specific use case that are not already part of the standard. For example, a clinic that does medical tourism may want to record a patient's nationality, which is not part of the standard patient resource. They can simply extend the patient resource to add a nationality extension. When FHIR extensions are created, they are published to a publicly available URL, meaning anyone who receives data that uses the extension can discover what it means. Finally, when it comes to putting the FHIR standard into use for a specific purpose, you can refer to FHIR implementation guides, which contain the profile resources, including extensions, terminology bindings, and value sets needed for a particular use case. Beyond these technical details, FHIR implementation guides provide documentation and examples of how they might be used. These guides are published to a publicly available URL using a web publishing tool made by HL7 International as part of the FHIR specification. Since they are machine-readable, FHIR implementation guides can be used to validate FHIR applications developed by using them. To learn more about the FHIR standard, refer to the other content on the InterSystems Learning site.